Hello my dear children, happy to meet you all again with yet another video on metallurgy. Today we are going to discuss about the metallurgy of copper. All of us will be aware of what the metal copper is and how much useful it is in our day-to-day life. Copper was earlier called as cuprum by the Roman. See what all things you can see here: jug, water bottle, tumblers, wires, all of them are made of copper. Copper is very essential in our daily life. It is used for making electric cables which are used in conducting electricity. Is it not? You can see the coin. It is one of the important metal in the coinage industry. Without copper, the coins cannot be made. You all must be knowing this metal, a very good conductor of electricity, is used widely in electrical appliances. Now let us understand the position of copper in the periodic table. Copper is found in the 11th group in the 4th period as Cu. Its symbol is Cu because it is called as cuprum. Its atomic number is 29. Mass number 63.54 and its valency being 1 and 2. Now let us know what are the steps involved in the metallurgy of copper. Concentration of the ore, roasting, smelting, Bessemerisation and refining. What are the ores of copper? The ores of copper are copper pyrite, cuprite or ruby copper and copper glance. The important ore is copper pyrite. It is copper iron sulfide. When it is a sulfide ore, what is the concentration process to be followed? We have already learned in the earlier video. It is froth flotation. What is froth flotation? Here, the crushed ore along with water and pine oil is agitated in the tank with compressed air. While doing so, the heavier gangue particles goes down the tank while the lighter mineral ore gets stick to the oil and floats above as froth. And this froth is removed and then goes for the next process. The concentrated ore is now subjected to the next process called as roasting. Here it is roasted in a furnace called as reverberatory furnace, where the ore is heated indirectly in the presence of air, where the volatile impurities like sulfur, arsenic, antimony are removed as oxides. And also they are converted into iron sulfide and copper sulfide partially. Roasting is followed by the next process called as smelting. Here the crushed ore along with coke and limestone is fed into the furnace called as the blast furnace. Here the ore is converted into iron sulfide and copper sulfide. The mixture of iron sulfide and copper sulfide together is called as matte, and in the molten state it is removed through the outlet given at the bottom. The slag floats over the matte is also removed through the outlet given at the bottom. The matte is now fed into the Bessemer converter. Inside the Bessemer converter, the ore gets oxidized through the air that is being supplied from the bottom of the furnace. Here, copper sulfide is converted into copper oxide and iron sulfide is converted into iron oxide. This iron oxide reacts with the sand to form iron silicate, the slag. Copper here forms blisters as the waste gases like sulfur dioxide move up, and therefore here the copper is called as blister copper, which is 98% pure. The next step is purification. Here the copper is purified by the process called electrolysis. The impure copper, that is blister copper, is taken as anode and the pure copper is taken as cathode, and a mixture of sulfuric acid and copper sulfate is taken as electrolyte. When the electrodes are connected and current is passed through, copper from the anode gets dissolved into the solution and gets deposited in the cathode. Impurities settle at the bottom is known as anode mud. Now let us see the reactions in each process. Roasting. Here the ore, copper pyrite, converts into copper sulfide and iron sulfide. Bessemerisation. Here iron sulfide becomes iron silicate, the slag. Then copper sulfide becomes copper oxide, and further it reacts with copper sulfide to form metallic copper known as the blister copper. Let me check how much you have understood the metallurgy of copper. Identify the furnace and label the parts. What is this? What reaction takes place here? And what is the product formed there? Identify this process and also try to label the parts.